What's going on, guys? In this video we are going to see how to do the proof by contrapositive. In contrapositive, what we do is we look at the terms after this then, and we find the negation of this one and put it as first, and we find the negation of this one and put it as second. We just switch it and negate it. Okay, now let's go ahead and do that. Here if you find the negation of this one, this is going to be x is greater than 1, and then if you find the negation of this one, x square is greater than x. Okay, now after we do the contrapositive, this is our contrapositive. Now after we find out the contrapositive, we just have to prove this one. We don't have to worry about the first term. Okay, if we can prove this one, then this is also proved, because contrapositive and this one is the original statement is always the same. So if you prove the contrapositive, it automatically represents this is also correct. Now here we are we know that x is greater than 1, it's given, and we know that 1 is greater than 0. So by transitivity, this is axiom number 13. I made a video on axiom, all of the axioms. I put the link of the axioms in the axiom video in the description, so you can go ahead and watch them. Axiom number 13 says transitivity, like when you have comparison like this, you can just directly write x is greater than 0, right? If x is greater than 1 and 1 is greater than 0, you can directly say x is greater than 0. So this is by axiom number 11. Actually, this one is 11. Okay, axiom number 11. Now the next thing is we are going to do the axiom number 13. Axiom number 13 says when you have x is greater than 1 and x is greater than 0, you can write it as x is greater than x1. So how did we derive this one? Axiom number 13 is basically when you have x is less than y and when you have 0 is less than, this is the common thing. So when you have these things, you can write it as xz is less than yz. Okay, so we can apply for anything in axiom 13 for this one. Like for this one, if you arrange this one in this order, here we have what? We have 1 is less than x and we have 0 is less than x. 0 is less than x. So here you can see this one first and that one comes here. Here this one x, and then you multiply these two and that comes here. So this one is x square. Okay, or x times x, this is 1 times x. That's what we have right now. Now we have this one, then we can say this is equal to x square is less than x times 1 is equal to x by identity of multiplication. That's axiom number 7. By axiom number 7, you can say 1 times x, or x times 1 is equal to x. So this is what we want to prove, right? This is proved right here. Therefore this one is proved. And that's how we do the proof by contrapositive. And if you are trying to learn discrete mathematics, there are a bunch of videos in my playlist. I hope you guys watch that too, and don't forget to subscribe. See you next time.